Alright guys, we got a little project here to get to. What we have is a cast iron exhaust manifold that's got two studs that are completely seized off there into the casting and broke off. And we've also got this butterfly, which he said just to cut this thing off and just remove it. He doesn't need the butterfly, just wants it out of there, so we're just going to remove that. So we'll just get in there and cut that pin and get that out of the way. But we've got two studs that we need to see if we can get out of there. And this is pretty old. This is original equipment, and this is obsolete stuff right here. I cannot recall offhand. Maybe I'll have it in a video of what it was, but I believe it was an Oldsmobile, and I don't remember, a 60-something car, and it's an obsolete part that you can't find. So that is why he's wanting me to try to get these studs out of there. So they're definitely going to be stuck in. You can see the back side right there, how it's just completely corroded away. There's still one or two of the threads left, and that side there, you can see it's just worn away. So there may not be getting this out of there as far as extracting it and getting it back out. This may be completely drilling it out of there and having to run a tap through the hole to clean it up. I don't know how it's going to work out yet. But what I'd like to do is go over there to the welding area, and I want to get this thing cut off, and I want to do some heating on this, do some preheating on these areas where those studs are, to try to get everything to expand some and retract, and hopefully maybe get it to kind of break loose whenever we get to the machining side of it. So we'll set it up on an angle plate in the milling machine down there and get it leveled out good and center up and start cutting them out. No real simple way to get in there and cut that rod, so I'm going to use this carbide grinder and try to split it in a couple pieces so that it'll all just kind of fall apart there. Alright, there's the other piece. We will have to fill in that hole there. That shouldn't be an issue. We'll get that, braze it in. We're just going to let that cool. We'll let that cool tonight, and I'll come out here in the morning and start getting it set up in the mill. As I said, I wanted to do that just to try to hopefully help the cast iron and the steel to separate, and maybe we'll get lucky and get it out of there. Since it's a through hole, it's possible that we could start drilling in the center of that thing and it get enough bite on it that it actually break it loose and spin it out of the hole, and that's what I'm hoping for. But there's cases like this. This is a good example where the metal just grows together so hard that it's not going to come loose, and you end up having to just cut every single bit out of there. So we'll find out tomorrow. Either way, we're going to get it out of there and get it fixed up. Try to give you a little close-up shot of what it looks like. I don't know if this is going to make any difference or not, but I'm going to put a little bit of this knocker loose on there just to see. I can kind of see the outline of where the original thread is. We'll put a little in there and see if it'll work its way down in that crack. And I'm going to start setting it up in the mill. We're using my adjustable angle plate here, and I finally got it bolted in there, and I'm just going to use this this little stair at precision level right here, just to eyeball level both directions. So I'm just going to use this reference surface right here to get it leveled in. I got a couple of T-bolts coming through, and luckily a couple of the holes are drilled 1/2 inch, so I was able to stick it right onto the studs there. And we are just about lined up that way. There's not much room for movement there, so all right, this way. All right, that's pretty good right there. Okay. All right, I think that's going to be where we need for getting a couple of bolts out of there. Those should be a 3/8 diameter stud. I'm using a 3/8 end mill, and this is typical for how I try to center up a broken bolt like this. I've just used the end mill to try to find center location both in X and Y axis. So I just turned the end mill, so right there we've got it turned into the Y axis, and I just adjust the table to where it looks like the end mill is on both sides of the bolt evenly. And then the same thing, I turn it to into the X orientation, and then I move the table where it looks like it's going to be centered up on the bolt. And then once we have that, we're not going to be absolutely perfect, but that's going to usually get you close enough to get the bolt out. I'm going to lock the table, zero out my DRO, and then what we'll do is we'll cut a flat spot there. Once we get a flat spot, then we'll go to our drill bits. You want to create a flat spot so that your drill bits don't walk off to the side. All right? So let's see. At least it ain't hard. Not like hardened steel, I mean. All right. And then see, once you touch all the way around, it kind of gives you an idea whether you're centered up or not. It looks like it's pretty close, but it's off in the X orientation just a little bit. So I'm going to move the table over a little bit further that way to right about there. That looks pretty good. That was 15 thousandths that I moved it. Let's go ahead and hit it one more time. Get centered up on it. Okay. I'll put a drill chuck in there and we'll go ahead and start drilling it now. I'm going to use a center drill just to spot the center, create a little divot. And I'm going to use a stubby link drill there, 1/4 inch. This is a new one. It's got a split point grind on it. And I think we're running at a pretty good speed. We'll try that. It might still be a little too fast, actually. Yeah, let's slow it down. That's 325 RPM. Let's go to 210 on my step pulley. I want it to try to catch the drill and apply enough pressure on it to break it loose and spin it out of there. That's what we're attempting anyway. And it just feels like it's going to drill it all out of there. See if it catches it at the end. Nope. So that's what I thought it was going to do. Just drill it all the way out. So that's what we'll be doing there. Go. Now that's one drill bit size under tap size. I usually do that just in case I'm off just a little bit one way or the other and I'm not cutting into the threads. So it looks like we're pretty well centered up though. Cool thing about it being 3/8 is that our tap size is 5/16, so I can use an end mill there. So I can visually see, I can't show you on that video, but I can just see the thread starting to cut through on this side and it's not on this side. So that allows me where I can actually adjust the table over. I moved it over 5 thousandths. Then it will just plunge with a 5/16 end mill to try to cut the rest of the bolt out of there. And just do a little bit and then look at it. Exactly what I thought. It was just completely stuck in there. I was able to peel that first thread up. It's probably going to break though. What do you think of that? Ah, there it goes. Okay, I got a lot of it out of there, so yep, looking good. I should be able to run a tap in there now and clean the rest of it out. It pushed the rest of it out down on the bottom there. Okay. All right, we got one down. All right, one down successful. One more to go. Just checking the fit on the thread there. All right, we're going to do the same thing. I'm going to use this 3/8 end mill here. I'm just going to use the drill chuck this time. I got to swap that to collet and then find the center. This one's a little bit harder to figure out where the actual center is. Same thing, we'll use a 1/4 inch to get a hole through there, and let's hope that it breaks loose and spins out. Ain't gonna do it. Using the 5/16 10 mil now. Until I need to go that way a few thousandths. There it goes. Right there at the end, it caught it and it screwed it down, and I pulled back on it so that it wouldn't pull the end mill down onto the top there, but there you can see part of it right there. So it caught it there at the end. All we gotta do is just run a tap through there, clean the hole up. All right, we're going to get it out of here, and then we'll have to go back over to the welding area, and we're going to braze up this hole. Thought I'd show you what it looked like, since I didn't show you what everything looked like going on there. There was the 2 holes that we used, and these are the T-bolts that I have that fits this angle plate real good. Another thing we want to do while we got it is we want to check the flatness of this machine gasket face right there. I'll use my straight edge to look at that, and we'll just clean it off real quick with a wire brush. Looks pretty dang flat to me. It is nice and flat. I think you've got good contact there all the way across, especially if you put a new gasket on it. I think it's going to be fine. Yep, I don't see anything wrong with that. If that thing was rocking or we had some hills and valleys in there, I would see, you know, taking the time to set it up, but that thing is flat. And that is a precision straight edge. We actually had that reground, so it is, I believe it was within like a tenth or two of being flat all the way across. So that's looking good. All right, I think we're going to leave that face alone. A new gasket, that should pull up just fine. The reason that it was, I'm trying to remember now, it's been a little while. He had pulled this off because he was doing some exhaust work on it. And then of course the studs were broke there, so that had to be fixed to be able to put this back on there. So he had to take this off the car. So he just wanted me to check it while I had it in my hands there. So that's the hole that we got to plug up right there. They've got a ceramic bushing in there. We're just going to leave that. We're just going to leave that in there. It shouldn't affect the brazing. So I just want to clean this real good here, and then we'll just build up a circle till we close up that hole. All right, let's get this thing brazed up. We're going to be using our flux coated brazing rods. These guys right here. I'm going to use that. Go. That's all it took. All right, so we'll let that thing cool down. I got it sitting on fire brick. We'll just let it cool down today, and then we'll just clean it up a little bit. And other than that, the thing's going to be done. All right, guys, we got this one done, and we were very successful with this on getting our two broken studs out of there. Worked out real good. We got our hole brazed up there because they're eliminating the choke little butterfly for that, old school. And again, as I said, this is just this particular manifold, as he said, is an obsolete part. It's extremely hard to find one, even a used one online, because it's such a rare item that are not made anymore, and there's not many of these things floating around. So he was just trying to fix this so that he could use it again, and I was glad that I was able to help him out. This was one of my it's a local viewer named James. He lives here locally, and he contacted me a while back about maybe trying this, and I was glad to help James out with this. So, all right, that's it. I've got some more job shop stuff coming in here. Got a couple more jobs that's come in, so I will have some more machining content to share with you pretty soon. I've been working on this. I've been working on my vise rebuild, and several small little projects going on around here. All right, so hope you guys enjoyed, and we'll see you again on the next video.